Hey guys, welcome back. Today's lesson is pretty much going to be a repeat of the last two. I'm just going to add one tiny little piece at the end. Okay, so here we go. First of all, same rules. These are your derivative rules. So I just want to remind you of when you work them in reverse, you're doing an antiderivative or integrating. Focus on the couple that you tend to forget. This guy, derivative of natural log. In reverse, the integral of 1 over x is natural log. And this guy, if derivative of tangent is secant squared, then in reverse, the integral of secant squared is tangent. Okay, so this is all stuff that we already did yesterday. Hit pause and quiz yourself right now, and let's see if you get those right. Okay, let's see how you did. The integral of cosine is sine, so we bring down the -3. Don't change the sign. Okay, leave the inside the same. And divide by the derivative of the inside, which is 5. So -3/5 sine of 5x minus 2 plus c. Now, by the way, I think I mentioned it yesterday and or the day before, but this dividing by the derivative of the inside, you can only do that if the derivative of the inside is a number, not a variable. Okay, and that's all I've been giving you so far, so it works, but I just want to say that technicality. Okay, the next one, the derivative of e to the 5x, if it was derivatives, the derivative would be e to the 5x times the derivative of 5x, so times 5. So when we integrate, we do the opposite, divide by the derivative of the inside. So this would be e to the 5x divided by the derivative of 5x, which is 5, plus c. Okay, the last one looks easy. It's just a power rule, okay? We're going to do a power rule, but often people miss this one. So we're going to treat this one just like if it was 6x to the 5th, okay? If it was that I was integrating, I would add 1 to the exponent, which would make it a 6, and divide by 6, and I would just get x to the 6th, right? Plus c. Well, this is the same thing, but you got to also remember to divide by the derivative of the inside. So I bring down my 6, do my power rule, add 1 here, leave the inside the same, add 1, and divide by that result, right? But that's not all. You have to also divide by the derivative of the inside, which is a 3. These 6's will cancel, and I also need a plus c. So you can write it as dividing by 3, or you can write a 1/3 out front. Either one, they're both the same. Okay, there you go. Hope you got those right. All right, now this is also not new, what we have here. It's just that yesterday's lesson was so messy, I want to make sure I reiterate this, okay? All right, the difference between these two problems. Look at how similar they look, okay? This one, I make it a power rule, move the exponent up. Remember to keep this integral symbol because we haven't done calculus yet. Then when I integrate, you get rid of the integral symbol. So I'm going to integrate now. I'm going to add 1 to that. And you get 5x to the -2 divided by -2. Or -5/2. And I probably move that back to the bottom. Okay, so this is a power rule. However, this one looks the same, but if you try to do the same thing, it doesn't work. I'll do it wrong just so you can see, because this is probably what would happen to you when you're doing your work. You'll do it wrong, and then I want you to see what happens when you do it wrong, so you recognize it. Okay, so if I move it up and do the same exact thing as we did for this problem, when I go to integrate and I add 1 and divide by the result, you get division of 0. That's supposed to be your clue. Uh-oh, this is not the same thing. This guy is actually a natural log problem. Because remember, the derivative of the natural log of x is 1 over x. So when we work it in reverse, when you have an x to the first in the denominator, that's a natural log problem. Okay, so let me get rid of it and do it correctly now. So since this is an x to the first, this is just 5 natural log of x. And since you can't take the natural log of a negative number, we always put it in absolute values. Okay, so study that one right there. That's a big one. All right, this next is the same concept. Okay, look at how much they look the same. This one though, whoops, hold on. Okay, this one is junk squared, so I can do this one with a power rule. This one is junk to the first power, that one's going to be natural log again. Okay, so let me do this one first. I would rewrite it, move all of this up, and do a power rule. Add 1 and divide by that result. So I get -1 divided by -1. And then I also have to remember to divide by the derivative of the inside. Okay? And then just clean it up. So I have a -4 in the denominator or a -1/4 out front, either way. And then I'm going to move this back to the bottom. Okay? So this one is a power rule again. This guy is natural log because it's junk to the first power. Notice it's not an STD. It's not where you can split it up. It's not a single term denominator. Okay? This is just the natural log of 4x plus 3 divided by the derivative of the inside. Okay? So study that one. Here's one more just to make sure you got it. If I asked you to do the integral of, say, 3 over 2x plus 1, okay? Compare that to if I flipped it, 2x plus 1 over 3. Very different problems. The first one is a natural log. You bring down the 3. Natural log of 2x plus 1. Divide by the derivative of the inside. That's that. This guy is a single term denominator that I can split up. So it's the integral of 2x over 3, which is really just 2/3 x plus 1/3. That's just 2 power rules, okay? Add 1 to the exponent and divide by the result. Add 1 to this exponent, and this would just be 1/3 x squared plus 1/3 x plus c. This is just a power rule, whereas the other one was a natural log. Okay, so that's all review. Make sure you guys are really studying those worksheets. Your next quiz is going to look just like those worksheets. Very basic. It's one that I think you can get 100 on. Just make sure you're treating each one of the worksheets each day. Treat that like a quiz of your memory, okay? All right, the only thing that's new today is what we call evaluating a definite integral, when you have numbers on the side there, okay? When that happens, I'm going to show you how we do it. I don't know if I'll quite get to why it works today, but right now I'm just going to teach you the mechanics of it. FYI, this is called the fundamental theorem of calculus, so we kind of do this a lot, and it's kind of important. All right, so when you see numbers there, we call it a definite integral. When there are no numbers there, it's an indefinite integral. All right, we're going to do the same thing. We're just going to evaluate the integral like normal, do the antiderivative. We're going to do a power rule. So the first term would be x cubed over 3. The next one would be 3x. Then we're going to evaluate that, and usually they write it like this, from -1 to 2. Now what does that mean? That means we're going to plug in the 2 for both of these x's, and then we're going to plug in the -1 for both x's, and then you're going to subtract those results. So I'm going to put this, okay? Plugging in the 2 to both x's will give me what goes here. Plugging in the -1 to both x's will give me what goes here, and then you subtract those answers. A definite integral will give you a number. Just like when we did derivatives, if we evaluated the derivative at a point, then we plugged in that number for x. All right, so we're going to plug in the number for the x's. Okay, plugging in the 2, I would get 8/3 minus 6. Plugging in the -1, I would get -1/3 plus 3. Now you just have to simplify that. Now, FYI, when you have fractions involved, it's often easier to not do this first and then subtract because of those fractions. I could change this 6 to 18/3 if I wanted to. But if you want to be able to do it a little bit more in your head, it's actually easier to distribute this negative and do the thirds first. I'm going to do this guy and this guy. So 8/3 plus 1/3 would be 9/3, or 3. Then the -6 minus 1 would be a -7, and I can do it a little bit more in my head that way. Okay, double check my math on that. I did the 8/3 plus 1/3, which is 9/3, and then I did the -6 minus 1, which is -7. Okay, So that's a definite integral. Before I show you what it means, because I think I still have time in this video, why don't you try another one? Hit pause and do this easy one. Okay, when you integrate, you should have just gotten an x squared. We're going to evaluate that from -1 to 2. That means plug in a 2 for the x squared, plug in a -1 for the x squared, and subtract. That's what you do every time. So plugging in the 2, I get a 4. Plugging in the -1, I get a 1. Subtract them, you get a 3. And that is the answer. And now let's see if I can try to help you understand two things I really need to do, though I might wait till tomorrow. I need to show you how to do that on your calculators, and I have to show you what it means. But since I'm already at 10 minutes right now, maybe I'll just have you guys practice it in your homework, and I'll show you why it is what it is and why it works tomorrow, okay? Hope you're doing well. Bye.